Oh, this is Old Electronics Fan, and I realized after I suddenly decided to film or record what I just recorded that I just started in recording and I didn't put any kind of an intro. And I want to explain a little bit about why I even bothered to do this. For an experienced electronics repairer, this is not an exciting video. This is aimed at someone who's maybe fairly new, maybe not all that experienced in electronics and troubleshooting. And the issue with the unit that you're about to see is that the display on it was blank. So the typical person who's not done much with electronics will look at that and say, oh, I can't repair that. And based on what I found for this unit, there are going to be times when you can fix it because the problem is very simple and very easy to repair. So the goal of this is simply to show people that there are some basic things you can do to check something out, and yes, there will be times I've run into them, you will run into them too, where you start digging into it, you can't pin down what is wrong with something. It's just outside of your range of knowledge. Oh, and the other thing that makes this particular unit difficult to repair is that there is no information on it. This RCA was built in 2000, and it's not an expensive unit. Although here we are, 22 years later, and it actually still works. Without the display, the thing actually would still play CDs, and it would change tracks when you asked it to. It just wouldn't tell you what it was doing. So you could have used it as was, but I decided to dig into it and see if, who knows, maybe I can find something. So what I have here on my bench are the basic tools that I used. This is an ESR meter that allows you to test capacitors in circuit. It's been extremely handy for me. You don't have to unsolder the capacitor to find out for sure that that's the bad one. You can go checking through the capacitors in your circuit or in your device. You find one with ESR that's out of range, and then you can remove that particular capacitor and then check to see if there's something else wrong with it. I've got 3 of these capacitors from the failed ones that came out of it. This one is supposed to be 100 megohms, or 100 microfarads, that would be better. And so I grabbed my full peak meter, which measures capacitance, and 4 microfarad is what it has. Not good. This one, the value was okay. It was around 0.9. It's supposed to be 1. But this was 14 ohms, well, 9 or 14 ohms depending on which one of these devices, actually I'm getting ahead of myself a little bit. Let's say that this was 9 ohms, 9.3 I think is what this read, of ESR. This is supposed to be down to like 0.3 or something. Maybe as high as 1, but that's it. See, that's let me just see what my chart. I have a better chart that I stored in my computer, but I'm too lazy. 1 microfarad, 50 volts. So this one goes down as far as 10. My other chart goes further, 50 volts. So as you go down in capacitance, the ESR goes up. So you might be okay at, say, 5 ohms. This was at 9. So it's not good. This one said it was 80 microfarad, and the ESR was, I think, the ESR was high. Well, let me just, let's turn you on. My memory. Okay, do not test now. How about now? How about now? Yes, I guess we can test now. I'm going to zero you out. Alright, there we go. Let's check you out. Make sure I have the right one, no matter. And yeah, 4.6. So this one is, what are you supposed to be? 100 microfarad, 50 volts. So 100 microfarad, 50 volts, so it's between 0.32 and 0.3. This is 4. So that shows you that capacitor is not happy. And but these are the only tools that I used to figure out what was going on with the circuit, the power supply circuit. Now, these aren't horribly expensive, but if you are operating on a really minimal budget, you can get one of these guys. I actually modified it. I added clip leads because I had these 3 little pads here that I could solder to, which I see my wires are breaking again, darn. This is designed for testing, it calls itself a transistor tester, but it tests transistors, capacitors. It can help you figure out what an unknown device is. It will sometimes read inductance on a coil and tell you how many henries it has, sometimes. I've compared this against these 2 items. They don't always agree. I much more quickly trust these than this, but this is a good and helpful tool that you can use. Now, the problem with this, though, you can't test the capacitor in circuit. So you are going to have to remove the capacitor, which you'll obviously need well, anyway, never mind. So you have to remove the capacitor from the circuit and then test it. And in order to read the values of these, the capacitance, you have to take them out of the circuit as well. So for me, this is my go-to tool when I'm looking at especially the electrolytics in a circuit. It's really saved me a lot of time because I start with ESR values that are a bit over. One of these capacitors, I don't remember which one. This one might have been reading at 4, and then when I took it out of circuit and checked it with my capacitance checker, it said it wasn't great. So in the case of my little power supply, it did not have that many capacitors. So the first thing I did was I went through and checked all the diodes. I used the diode mode on my meter. All of the diodes tested good. So that was my starting point. Because if something went bad in the power supply and it shorted out a diode, or the diode simply went bad, that's quick and easy to find. And then my next step was to go through these guys. Once I found that I had failed capacitors, I didn't go any further. I could have gone through and checked all the resistors. I didn't do that. Modern resistors are usually better. None of those were Allen Bradley or anything like that. They were probably film. So modern resistors are typically okay. I don't know that I can guarantee they won't be off value, but usually they're good. So, like I said, this is a fairly simple repair video. This is what was wrong with it. But the other part that I did, for those who might have an interest in this was a 5 CD changer. If you've never seen the inside of one and you wondered how they work, this is one of the ways that they work. They aren't all designed the same way. And as I mentioned in the video, this one happens to be pretty neat because you can start playing a CD, open the drawer and put in other CDs, take some out, and do whatever you want to while it's playing. And it will just continue playing along and ignore that you're doing other things. It's kind of a neat system. Like I said, it wasn't terribly expensive, but it's kind of neat. So I do show a little bit about the unit, what the display tells you when it's playing, because I do get the display working. So For those of you who think that, oh, that's a problem I can't fix, well, it's possible you can. These are not expensive tools. And like I said, if you absolutely had to, with the number of capacitors in that thing, I think there were 6. You could just replace all the capacitors if everything else tests good. And here's the key. Check your power supply. If it's putting out low voltage and you can't see any other reason for the problem, then you can, let me think, brain. Oh, then you go to the capacitors. There could be something else wrong with it, and you could replace all of these components and find out you still haven't fixed the problem. But, and unfortunately my phone is ringing away and no one's answering it. Darn. Oh well. I should have turned my ringer off. And I forgot. Alright, so anyway. So the reason I went in this direction is simple. Low voltage, which points right to the power supply. There could be, now, let me just point out that there could be a problem on the board that's being fed from the power supply, and it could be a short or something, and it could be drawing the voltage down, in which case you would have to then troubleshoot that. And I didn't do this, but you could unplug the power supply from the board that you have a problem with and see if the voltage on the connections come up to where they're supposed to. I didn't do that. Probably should have, but knowing the age of the unit, I pretty much expected that one of these was probably my problem, and it turns out I was right. I'm sure in the future I'll get bit by doing that because, well, I guess with this tool I can go through and I can say, oh, I can't find anything wrong. Now I'll go and troubleshoot to see if there's a short somewhere that I can fix. Oh, the other thing, let me just mention this. I have a little alarm clock radio somebody gave me because it didn't work. Brand new, Emerson, who knows who actually makes it, but the problem with that was a bad solder joint. It had a little cable that went from one circuit board to another inside the radio. And I checked it out and I spotted some solder joints that I didn't like the looks of. I resoldered those, and it works fine. It's been working fine ever since. So that's the other thing. In fact, that was one of the first things I did. I checked out the board that had the problem. I saw a solder joint I didn't like. I resoldered it. The problem didn't go away. Then I went to the power supply and started troubleshooting because I knew I had low voltage. That didn't fix my problem. There's a little board with a bunch of cables that were connecting. I looked at that very closely with a microphone. Here's my other tool, magnifying glass. So I looked at that board very closely. The solder joints were flawless. They looked beautiful. So I didn't look any further for problems on that little board, and then ultimately led me to the power supply. So, for those who maybe are not sure that you can repair something that has a fault like that, there's nothing to lose by going in and doing a few basic checks, because sometimes you get lucky. I got lucky. There's just a few components, very easy to fix, not hard to figure out, and so my bottom line is I'm just trying to encourage people to step outside the comfort zone a little bit and explore and see if you can maybe fix things that you didn't think you could. Bad solder joints, not hard to fix. Failed capacitors, very easy to fix. So give it a shot, you never know. And so now we'll go on with the actual repair that I did. And then after that I'll show you how the CD player works. Alright, well, I wasn't going to get into this. I wasn't going to film it. But, well, let me explain what I ran into. I forgot there were discs in this, so I flipped it on its back and all the discs went to the rear. And then I made the mistake of turning it on, and the tray came out. The tray wouldn't go back because there were discs there. So I took it apart, got the discs out, and then I noticed something. my display wouldn't do squat. I said, well, that's nice. Must be when the disc got into one of the pieces of wiring in there and it broke something. Well, I took it apart and guess what? It wasn't the discs. So I started looking for voltage. There's absolutely, I didn't even bother looking for information on this. This is a cheapy 5-disc CD player made by, supposedly made by RCA. I highly doubt it's made by RCA. Well, it says Thompson Consumer Electronics. I don't know if that was RCA's company. I don't think so. All right, now. So anyway, back to my tale here. So I started checking. I was looking for 5 volts to see if the power supply might be the issue with this thing, and I can't get 5 volts here. And I checked this wire. This wire comes from here, goes into this, and I think and it does. It goes over here into this, and it's a filament plus and minus. I didn't check there, but I got one. I had 1 volt here. I don't think anything on here would run off from 1 volt. So checked all the diodes. They seem to be fine. So then I started checking capacitors, and there's 2 in here that are not doing much. This one, let's see here. I don't know if I can. We'll just clip this on here. And that's ground. Yes, that's what I want right there. Alright, and don't make a liar out of me. Oh, see what that says? I don't see much happening there. It doesn't seem like it's doing much. And this is supposed to be 100 microfarad. So let's see what the meter says it is, or thinks it is. Alright, so ground plus 4.5 thereabouts microfarad. He's dead, Jim. So obviously that's not healthy, and I believe I said that the ground was going south. Let's see. Alright, so according to my memory and what I just took out, this should be, yes, so the positive side should be this way, and then the ground should be that way. Let's see if we can get you in there. Ew. This wasn't exactly easy to get into. Right, ground facing downward. Let's see if we can persuade you to do what I want you to do. I am not a solid state expert. I'm not unfamiliar with solid state stuff. I don't have a broad knowledge of various chips that are out there, like some other people out there. And it's been so long since I've actually worked on solid state stuff. Well, let's just say that my troubleshooting abilities in this matter are limited. So if I fix this power supply and I still don't have a working display, I suppose I could investigate to see what the filament voltage should be for a fluorescent display like this, because I believe that's what this has. I might look. I just don't. I don't ever get into this stuff very much. Well, very much. I'm being redundant there. I very rarely get into this stuff. It's not that I don't know something about it. It's just I don't do it enough. And it's, as you well know, if you don't do something for long periods of time, let's just say that your skills are going to be less than ideal. Now I think this little guy right here is also not healthy. And I'm going to go back through and check all these with this little thing here. What's nice is you can check things in circuit with this thing. Let's see here. Now let's check you. And it's headed. Which way are you headed? Alright, it goes forward and aft. And it's right there. Okay. Let's check you out. Right there. I think that's it. And that is okay. That's 9 ohms. Now that could be okay. Let's see, what's the voltage supposed to be on this? What are you? Where are you? 50 volts. Alright, so I'm looking, there's a little chart on here, and I have one actually on my computer. 50 volts. Well, unfortunately, this chart goes between 35 and 63, and only goes down to 10 microfarad. So let's do this. I know what that is. Let's check it with a brandy new one. And see what that one reads. And that's probably my best bet. 1, 2, 3, 4. 4. Alright. Let's see. And ground. .28, and this is 50 volts, 1 microfarad. So I'm thinking that little guy is not very healthy either. Is it dead? No. Is it causing a problem? I'm not sure. But given what it would cost me to replace it, since I'm in here, I am going to do just that. I'm going to replace it. Alright. That means the ground side should be that way. Let's see. Alright. It is. And let's do, just for the fun of it, let's go down here. That's supposed to be a 1 microfarad. What does this think it is? So there's our ground. And 0.89. So the value is actually okay. Unlike the other one, which was terrible. Yeah, this is still saying 9 ohms, so almost 10. So I'm saying that it's not exactly healthy. So, alright, and I just had the one, there we are. And the ground went to the left. Alright. Okay. Now I think the this is so much fun. this thing's trapping the wiring underneath there, and I can't get it where I want to get it, position it, whatever. Ground goes that way. And come on. There we go. Now, I'll just throw this out there for anyone who might want to fix the power supply in their computer, which I actually recently did. If your power supply hasn't terminated important components inside, and it's just simply not working, a quick check of that would be to look for any capacitors that have swollen tops. And those of you who are been around electronics any length of time, you will know that's a quick check. The only thing I would suggest is you don't rely solely on that, because you can get fooled into believing that even though because the top hasn't swollen, it's fine. In fact, let me look at. If you look at the top of this one, it's just fine. This is the 25 volt 100 microfarad that was reading 4 microfarads. So if I simply relied on the top of this. Now the other thing to note though is that these small capacitors don't have a split top, so they're less likely to show you that they're in bad shape by doing that. They have less material inside, and they are less likely to go bad. And this one also doesn't have a split top, and it doesn't tell you that it's not exactly healthy. So my last step is to do a quick check of the other two. So I've replaced these two guys. So I've got 4 more, and I ran through them, but I want to make sure, because it seems to me I wasn't paying attention to where the ground was, which is not a good thing to do. All right, so let's check you out. That's a 0.9 ohm also, and that's I think it's another 100 ohm or 100 microfarad 50 volt. Yep, no, 25 volt. So 100 microfarad 25 volt. Well, according to this, it should be about 0.3. So that one is not healthy. So let's replace you. I think that's the one I was just on. Time to double check. I get talking and I forget where I was. Oh, come on. Don't fall off, please. Yep, 0.9. Not healthy. And that was 25 volts, 100 mics, I think. Well, let's pull it out and replace that one, because I'm thinking this one is not entirely happy also. And we'll check and see what the value of this guy is. I don't have any device that will give me the value when it's in there. And so my plus goes that way, and that's true, that's what it says. Let's check you out. And it's 100 mics, or mics, yeah, 100 microfarads. What are you really? Let's see. Well, it's actually not terrible. Yeah, it's dead on. So it might be a little bit leaky, but the value is actually not bad. But guess what? I'm in here, I've got it out. I am going to replace it. Makes sense to just go ahead and do that. Let's see, so there we are. Alright. Yeah. So anyway, so I was actually given a computer because the owner didn't want to spend the money to fix it. So I took it home, checked it out, found out it wasn't producing the correct voltage, and so popped the cover, and I think in that case the faulty capacitors had started to pop their top, so to speak, and and I did the right thing, and I pulled used capacitors out of another broken computer power supply. Of course, I tested them before I decided to use them. Put those in, and it came right to life. And that was 2 or 3 years ago, and the computer runs 24/7. I leave it on because I'm treating it like a little server. It's not critical if it works or not, but it's just handy to have shared files. I mean, I do have a OneDrive account, and I share things that way, but I didn't pay for the full OneDrive account, so you can run out of capacity pretty quickly if you start storing a lot of everything on OneDrive. So I 50 volts, 100. All right, let's see how you look. So I just keep, oh, where's my ground? It's on the bottom. All right. So there are files that I want to install, files that I share between computers. All kinds of stuff I store in there. And 0.35. That one might be okay. Did I say that was 100 microfarads, 25 volts? So 0.35, it's on the edge, but I think we'll live with that one. This one's 50 volts, 100 microfarad, and the ground goes that way. Alright, so, come on, stop. 0.376, yeah, I'll live with that one. And lastly, this one, and the ground is in the back. I believe we're right there. This is a little bit of a pain. I know why they have the short leads, but that one's 4. So that one's edging up a bit, and it's 150 volt, 100 microfarad, 50 volts, 4. I'm going to pull that one, just like I said, because I'm in here, and I've got spares if I want them, or need them rather. Well, I don't know. Alright, come on, cooperate. There it goes. My tip was dirty, didn't want to transfer the heat. Okay, so my ground is to the left. Of course it tells me there, but I like to pay attention to that as well. So my next step is I want to see what value it thinks it is, because it's not fully in spec anymore. So I'm just curious to see if it's good or bad. Yeah. it's starting to head south. Let me show you. That's not very good, is it? Alright. It says it's 81 microfarad, which means it's more or less working, but you usually don't want to go smaller on your capacitance than it actually is, or than what was in there. So right now it is smaller than it's supposed to be, and that's 100 and it's 50. Well, that one is 100 volts, which of course will work fine. Yeah, okay. Problem is, will it fit? Yeah, I'm not so sure it will. Oh, I don't want that there. Can we? There you go. Well, it just might fit. I don't have a clearance problem. Yes, I think that will do. Okay, we'll double check this one, make sure. This is not brand new. I know I'm pushing my luck a little bit, but if it passes the two tests I'm going to make on it, that is a 0.160, and this is 100, so let's see, at 100 volts at 0.15, it's very close to what it's supposed to be. Here we'll do a final test with the value. See, I don't really trust just one test on a capacitor. I want to know value. Yeah, it's a little higher, but I think I can live with that. And if this doesn't work, of course I'll be left wondering, is it that one capacitor that I put in here that may or may not have been all it could have been? We can only hope that it is. Alright, let's see. There, it dropped right in. Perfecto. So, when I pulled the other capacitor out, of course it took solder with it. So I always like to add more to make sure that we don't have a weak solder joint. Okay. Now, so these are the dead ones. Yep. Put those over there. Now, yeah, it's about time for another battery in this thing. Okay, let's see what we got. So, if this solved my problem, we will have a display. And there it is, standby. Guess what? I have a display. So the power supply had failed capacitors in it. It wasn't that hard, other than a pain in the neck to take apart. This was hiding under this, the power supply. I could see the transformer peeking out through the back here. That's all I could see. So, working with this older stuff that there's simply no information on. You might be tempted to give up and say, I can't work on that. I don't have a schematic or anything. Something like this, where you've got, hello, yes indeedy. Oh, that makes me very happy. So something like this, where you've got a display that doesn't work, and you know it used to. And what was nice of them is they put voltages on the circuit board, so I was able to check and see that what I was seeing there was not what they were telling me I should see. So that was a big help. And when I checked this, the voltage on this line seemed very low, very low. So those were clues that told me my power supply was my culprit. And sure enough, I will put this back together. It will go back into service. It will probably outlast me. I don't know. I mean, I say that. I mean, this is not high-end stuff. This is a rebadged Thompson's consumer electronics device, rebadged as an RCA. And but you know, I'm trying to think. Well, 2000, so it's 20 years old, and it's still. I mean, even without the display, this thing was working. It was. At first, I thought, oh, I broke it. It's not even playing. And I thought, you chucklehead, you didn't even hook it up to an amplifier to see if it was playing, because I was listening to the CD player, and I thought that doesn't sound like it's working. Come to find out, it really was. So I goofed on that in that area. So now all I have to do is put this back together, and I'm done. So it's interesting that the only thing that failed was the display. So these caps in here were only the only caps that failed were ones that affected the display. Hard to say why that is. Maybe it's the size of them, but you know, this is 150 volts, and I think some of these are 150, 100 microfarads, 50 volts, and now the smaller ones went south, but I don't know for sure if that's something that you can expect. I certainly wouldn't go in with this, making the assumption that, oh, it's probably all the little ones that are broken. I wouldn't recommend that. You could fool yourself quite easily doing that. So don't. All right, so I will be back. All right, so what I wanted to do, and what I'm going to do, so I decided, you know, not all that many people have seen one of these multi-disc players, and there's a bunch of different ways that they do the multi-disc feature. But one of the things they did here, let me see if I can zip in there and show you. Simultaneous play and load system. A lot of these things wouldn't let you do that. Let me show you what they did. Notice each of these has a cutout. Let me bring you up a little bit here. All right. You've got your tray. In fact, let's plug it in, and I will show you how this works. So I thought, you know, some people might be interested in this. Power. Oh, it's telling me hello and everything. That's a good thing. So I was looking for discs. Now, let me throw. My wife loves Christmas music, and no disc. All right, fine. Actually, I can't do. I could do that, but it won't like it. Oh, and I want to. This tells you it's got a light for each disc, and so I think each light lights up when it detects that there's a disc in that spot. Right now, also it gives you a number on each side of the tray. So if I want to move this and position this, say I wanted this disc to be in number 1. I just hit that. I say close. So now that disc is in there, And I'm not gonna play the audio because YouTube is entirely too efficient at nailing if you have copyrighted music. So all we really want to see is how this works. Now, let me just show you that it is indeed playing. In fact, it shows you on the front here that number 1 is spinning. Very nice of it. So let's see here. Oh, you know what? If you plug the audio cables in, I have to put some screws in there because I took them out. I probably don't want to be pushing on that without it being secured. It's kind of funny, you know, there's two things you need in order to make things play. You need power and you need audio cables. Did you know there it is. That you baby. So, that's my little PA amp, which actually, through my tag sale speaker, sounds pretty good. Alright, so now this disc is playing. You can open this and throw another disc in there. In fact, I can throw 2 more discs in there, and now it will discover them. Of course, I put 4 and 5 in there. So now if I say I want to do 4, whoops. And there you go. And now if I wanted to take, oops, you're supposed to, okay. I don't think it was playing, so let's close this, let's play it. That's the other thing that it will do is if it's not actually playing the disc, then when you hit the open drawer, it will drop the disc onto the table and take it out, and you can take it out. Which means you can't take it out if you don't do it that way. Alright, so now, it's floating around, where's the set? Where's the set? Oh, no I don't, because the disc's upstairs. So anyway, you could, while that's playing, you could throw in other discs and continue to listen to whatever it is that you had in there already. And this is now telling me that number 4 is playing. It also tells me which track it's playing. Let me throw this at you. Let's see here. Is it back in there? Yeah. There it is. So it's telling me that disc number 4 is playing and track 1 is playing. And if I wanted to go forward, I'll just do that. It says it's going to go track 2. And now it's on track 2 blinking. And there it is. It's actually a pretty neat little machine. Like I said, we've had it since around 2000. And I think this is the first time I've actually had to work on it. So, and this time I'm not going to make the same mistake I made last time. All the discs are coming out before I carry this upstairs. So I don't have to take the cover off and pluck my discs out from wherever they've decided to lodge. And whatever grease they used for this thing back in 2000, good quality stuff. Because it's still soft. It must be synthetic or something. But it was all over. It was all over the disc, some worse than others. So yeah, I'm going to. Did I turn that off? Oh, it doesn't matter. So when I get all done, all the discs are coming out. Because at this point all I have to do is the couple of screws I've put in the side for this, put the cover on, put all these screws back in, and I'm done. So I've shown you what I really wanted to show you, so I'm going to wrap it up right here. It's a very creative, very ingenious system. Some of them, I have a Sony over here. It is a RCA RP8075RS. You should hear that thing when it's swapping discs. I've never had that one open either, and I have no idea what it's doing, but I don't think that one lets you swap and play. I don't think it does. I'll have to experiment with that one. But I know that a lot of these you couldn't. If it was playing, you couldn't put more discs in the tray. You had to stop it, bring your tray out, put more discs in, and take out whatever you want to take out, etc. And then you could put it back in and it would play. So I thought this was a pretty neat system. It works really well now that my display is working. I'm pretty happy about that. And I'll wrap it up. I'm not going to yammer. See you next time.